But I do ask at this time if you could mute your mics. Just everyone's kind of working from home and stuff. You have dogs, kids, stuff like that. And there's also some of them I can get, hear myself talking. So if you can mute your mic, and then if you have any questions, feel free to chime in. All right. There we go. So we're going to set up an S7 1200. This is the basic one that I have in my lab, and I do apologize, I do not have it with me today. But this would be the same if you're using other 1200s or 1500s. We do have on the danfossdrives.com starting there. These addresses may not be correct anymore. I'd have to look them up, but we do have the GSD files for the Profibus options through the downloads section, as well as there's Profinet. The setups between Profibus and Profinet are the same. Even the function blocks are the same. Just the only thing different is the identifying file that you would use. So to start configuring the PLC, you would open your TIA portal. And in this example here, I'm using version 11. I think now, I forget if they're 15, 16, or 17. But again, when we talk about the GSD or function blocks, they get compiled into the project and updated and go with the project. Anyway, excuse me. Okay, so we start the TIA portal, and this would be the window you would be presented with, and then you would create a new project. You would name your project. It usually starts with project or one or something. And then just click the create button on the right-hand side there. And then you'll be presented with a window here for configuring a device, write a PLC program or an HMI screen, and there's also a project view. Going into adding a device, this is where we're going to add our PLC. Different ways to do it. You can pick if you know exactly that usually the code number is printed on the PLC under one of the flaps, or there's a way to discover it. In this case, this one we're going to do an unspecified to do an auto discovery if I don't know what it is. So we choose it and then click the add button. And instead of being a blue PLC, I'll give this ghosty kind of white one in the project view. So device isn't specified, it'll say there, use the hardware catalog or do the detect. So under options, where am I? Let me go back a little bit. Okay. So at this point, yeah, they have the PLC set up and they're going to preset also putting in the drive in the catalog. So that's done to install the GSD file in this case, or GSD ML for Profinet. You go to options on the top and install the station description file, the GSD file. So like I said, same thing, even if it's a GSD ML for Profinet, same selection. You'll be presented with this screen, where would you find the files, where you have them saved after downloading them. Remember to unzip them and just have the extension exposed, GSD or GSD ML. It won't be able to find them within zip files. But then you would, to change the address or browse, you would click on the 3 dots on the right, a menu kind of button, and it will come up where you can browse to where they are. Then you just selecting a folder, then press the OK. And it will look in that folder and pull up all the ones that it finds in that folder. In this case, it's a Profinet. I know that because it's a GSD ML file, as it's named. And then you click the install. It asks right away, you know, do I want to make changes to the project that I'm using, adding the GSDML? I'll say yes. And once it's done installing, it will want to restart the TIA portal. You just press OK. It does the installation. You get a progress window. When it's done, you have the choice to click on Close TIA Portal, and it will restart the program. And you'll be presented back to the start again in this kind of project window. You'll open the same project that you were working in. You'll open the project, and then you'll be back to this window. And so we can go into the project to PLC1. That's the default name it gave the PLC. And we'll be back to this window at where we were at the point of adding the GSD file. So now all the files are in, we can go ahead and detect our PLC. When you click detect, it will come up to this connectivity area. At the top, you're going to pick the type of interface. We're going to use the PNIE internet connection. And then you say which interface you're using, which is usually the name of the device for your Ethernet adapter in your laptop or PC. In this one, when it looks, it will find the available devices, as there's the PLC it found, as well as the drive is there. If the drive does not have a host name in there, the name will be blank. Now, setting up the drive, which we'll get to that, setting up the drive, it's identified through TIA portal and the PLC, not by the IP address that you gave it. You can set the IP address, but there's a protocol there, and they're identified by the name that is set in the 12-08 group. It says host name, but that is actually the device name, and it is case sensitive. But in here in auto detecting mode, it would come up to what it's named. But if it doesn't have one at the time, it will be blank here. Well, at this time, we'll pick the PLC. And what's this one? Yep. Yep. Click detect. It will pull in the PLC, and you'll get a gray indication that it's a live PLC, and it has its type of name. And in the lower window about the device has all, you know, the I/O and the memory address locations. At the top here, you have Topology View, Network View, and Device View. At this time, we'll choose the Topology View. This kind of lets you connect devices. So I'm going to browse through the catalog down to other field devices to find the drive. And we're going to do Profinet drives, and then you'll see Danfoss drives, the FC series. And you select the head module, and it will come up as a Danfoss FC PN. You can drag that over into the window, and it will come up at this location. And in this area, you'll see the Ethernet ports are green on the devices. So you'll grab one of the green ports and drag it over. And this is, in the drive, it's represented by its 2 ports on the adapter. Now, when you drag it over, it'll create this connection between the 2. But at this, you'll notice that it is highlight here that it's not assigned to a PLC. So there's a interconnection happening, but it's not assigned to it at this point. So you'll change to the network view. And then at this point, the not assigned will be blue. It'd be a clickable link. So we'll click on it, and it will let us select the controller to assign it to, which will be the one that we're programming over here. So it had the PLC one through Profinet Interface. Once it's assigned, it will show up, change the link here, and then it won't be a solid green. It'll be a green with a white connection with the name of the interconnection assignment. Now you can have projects that have numerous PLCs and drives in the same network, but each drive needs a master PLC assigned to it. That's why in TIA Portal, why they have this secondary connection to assign who is controlling what. Now we can click on the highlighted drive and go to Device View. And now in this area, the device view, we can select the type of PPO. What kind of telegram are we going to use? And the PPOs in the for Profibus and Profinet is how many words of data we're sending in and out. So there's 1 through 8, and it has a varied size of words, like I said, in and out, which you can have just the basic 2, control word, reference word, status word, and main actual value, or the extra programmable configuration data, PCDs, we can get from the drive that we can add motor current and so forth. As well as there's about 3 PPOs that also have words extra in for the first section, which is a parameter access channel, where we can, other than the cyclical PCDs that we were just talking about, we can get any parameter from the drive through a type of a extra explicit message through that channel. So in the catalog, we can look under the drive, and then this is where we will see the supported PPOs. This presentation was created when we only supported 5 of them, but we do now support all 8. We didn't have so the ones missing here, you see there's no 1, 2, or 5. Those are the ones with the parameter access channel, but we do support them all today. But in this one, we're going to do the basic 2 words in and out. When you pull that in, drag and drop, under the interface, you will see how many words. There is no parameter access point in this one, and the addresses, the I addresses, input to the input to the PLC, and the Q writing out to the drive addresses. It will be auto selected for those numbers. I clicked too fast. By pressing the arrow down between the 2 screens, it is possible to minimize the device view. We can go to the diagnostics, and this is where we can give it the name. As you see up here, the name will show up here as well. We can type it over here. We can change it to match what is programmed in the drive. And it has to match, it is case sensitive. And notice it changes up here at the top. And like I said, the host name is case sensitive. And that parameter again in the drive is parameter 12-08. I will show this later through MCT10. Now we can click on the Profinet interface. And this is where we can type in the IP address we want to have in the drive. The PLC can set the IP address in the drive. Like I said, it identifies the Profinet identifies the drive by the host name. The IP addresses can be preset, but the PLC can change it. So mostly the only thing in the drive other than extra PCD parameters is just the host name needs to be set. You don't have to set the IP address. Mostly if you want to preset it, it would be more for discovering it through MCT10 or for pinging the drive. In the top left corner, we can change from the from drive to other devices, like the PLC in this case. Once we're done now, as we have it addressed, we can download these settings into the PLC, which is in the upper top there. TIA portal will compile the program. You'll get this load preview, and you want to mark override all. Once you click that, click on the load button at the bottom, and it will start downloading. Once it's done, you'll be presented this window. It's all done, and you want to click on the start all, that is checkmarked, and then click finish. And that's mostly it on setting up as simple as possible the PLC, the hardware setup, adding the GSD file and setting up the PLC to connect to the drive. Once that's done, the PLC is loaded. It should start communicating to the drive, and you'll notice that the LEDs on the option card, the Profinet card, will go solid green. They'll be full blinking previously, but they go solid green once there's a communication established between the PLC and the drive. So the PPO type 3 will start transmitting, and we'll see that. So now we can do some extra settings in the drive. Some of these should be default once we have the option in there, but the parameter 8-02 should be set to option A. That's the option slot for any serial communication cards, in this case, the Profinet. 8-10, the control profile is by default the FC profile. Now there's a Profi drive profile, and that changes the control word structure slightly, as well as adds a Profi drive profile has a state machine. Certain bits have to be turned on in a certain order. The FC profile is the Danfoss general control word profile, and there's no state machine. It's just state. So if you just send start, it will just start. With the Profi drive profile, you have to do a handshaking bit, turn on certain ons in a certain order. There's a enable, and then there's start. So unless you are using the Profi drive profile with other devices or it's a requirement from the customer, I suggest staying with the FC profile. It is a simpler control profile. By default for Profinet, this is the IP address assignment is DCP. This is how the PLC channel, the Siemens PLC, identifies the drive by host name. If this is changed to static IP address, certainly you can set the IP address and it will stay static. The PLC can't change it, but the PLC will not connect to the drive in that mode. It has to be DCP. The most common mistake is setting this to static and setting the IP address, and then the PLC won't connect to the drive. So leave it at DCP, and if it's not set to that, change it to that. And then in this case, the host name. It is set to, in this case, to match what we put in the PLC, FC1. I know it says host name. It's generally what you think it would be the host of a server or something, but it is the name of the drive for the host, the PLC in this case. And you can check the IP address that TIA Portal has assigned it. If it isn't already set to that, you will see it change once it connects to the IP address set in the program, in the PLC. Now in this, it's going to go into and how we can control the drive or set start stop in this presentation without using function blocks, but I'll show the function blocks after this. But we can go into the project again in the PLC and go into Plc Tags, and we will double click and show all tags. And then we can, shows all the tags are here, and then we can click on the field Add New. In this case, we're going to start with the control word. So the first tag we're going to call is CTW for control word. The data type is going to be a word. It's a 16-bit word for the drive. And then the address has to match the drive. So in this case, we're going to change it. Click the down arrow. And the identifier, it's going to be a Q. So this is a command from the PLC to the drive. So it's a Q. And then the address that we saw in the drive earlier, that's assigned to the drive from the PLC or from TIA Portal, so it's 64. And the operation type, being it's a Q, it hard codes it or grays it out. It's a write. We'll also do the same for the main reference value, MRV, and it's the next one, same thing, so it's going to be a Q66. These Q addresses are in bytes, 8 bits, so that's why there's a skip of 2. So that's why it's 64 is the beginning address that was assigned to the drive. So know that control word is byte 64 and 65, and then the main reference value is 66 and 67. Now the name here, you can name it how you want. We put CTW in this example and MRV. You can just call it control word all straight out, or main reference value, or whatever you'd like it to match. But later in the program, you'll have to use these names when you're writing it in your logic. Then we're going to set up to read the status word. And this is going to be a I from the drive. So it was addressed as I-70. I'm sorry, I-68, and then I-70 for the main actual value, the speed the drive is running. If you're not sure, again, you can always go back and look at the drive and look at the assignment that we did when we chose the PPO type. And in here, in this example, we also set some bits for the ladder later to set for start, stop, reverse bit, coasting, and always on for enable and disable. And then the main reference value or reference source, just tags for the PLC. So this is it for that we're going to set up for right now. And then we're going to go into program. So we can either double click it or use the left arrow to expand the view. And we're going to, in this new project, we're going to create a new programming block for the main object. So we're going to double click, okay, add new block. And here we're going to do a ladder, so it's the common name. Let's see here. So in here's 3 different kinds of blocks that we're selected with. We have a organization block. It's normally used in the programming block that contains the actual programming like conveyor 1, 2, and so on. A function block. This is code. This is a code block that stores its data permanently in the data block to make the data available, even the block is not being evaluated. And a function. This is a code block that will not save its data once it's not executed. It's usually subroutines and such. And then a data block. The data block is used to store data from function blocks. It can be used to hold values and configuration network elements like the drives, like if you're writing motor parameters and such. Programming the Siemens PLC and like other brands, there's 3 approaches. So there's ladder logic programming. There's function block programming, and then there's structured text. Is anyone familiar with programming PLCs? Okay.
Yes. Yep.
Yes. Okay. Do you have a favorite?
Well, what's out there? Hey, Joe, this is Jack Corza. How you doing?
Yep. All right.
What you see a lot of course, is Alan Bradley.
Mm-hmm.
So
yep. It's mostly ladder.
And then
but you
mostly ladder.
Structured text. You can do structured text in there though.
Yeah. Mostly ladder you see primarily because it's easier to troubleshoot for the guys in the field a lot of times.
And I believe that's what we're going to do in this example is doing ladder. I've set this up a long time ago, so that's why I'm kind of like, okay, what's the next slide now? But like I said, I'm going to show a little bit different things after this though too. So for this test system though, we need to save the data between reads, so we're going to do a function block. So to create the function block by clicking OK, and it creates it here. And what we're going to do in this, we're basically going to preset the control words bytes or bits to send in. So we're going to send in the start command, we're going to send in the stop command into the control word, and then different speeds. So we're presetting some data in here. So in the ladder, we're going to examine, so insert a button kind of thing. Let me see here. These are just saying what all the buttons on the top are monitoring. So we're going to insert a normally open, so these are different ones. They're just kind of telling you different types of buttons up at the top and what they are. Move data, add data, subtract, swap, the byte swap. Time delay on. Now this, after we're done, I am going to share a PDF version of all these. That's why I'm just kind of going through it really quick, just kind of clicking it. So in this case, in this one, though, we dragged in a normally open connection. Then we're going to move data. And in this case, what we did, so when the start bit is turned on, it enables this move. And this is the hex code to tell the drive to start, 047C in the FC control word. And we are moving that value to the control word. Okay, and I will show how this comes out to 047C. And this is the same as it is whether you are controlling the drive through Modbus RTU, Modbus TCP, Ethernet IP, DeviceNet, Profibus, Profinet, CAN open. Okay, this is the FC Danfoss control profile. It's the same. The only thing different is how we're transmitting that into the drive. So once you get to know the Danfoss control word, it's the same across the board. The only protocols that are different in that are the bit the protocols that are point-based. That's what I'm trying to think, point-based ones, like BACnet, because they have points assigned to certain things. But to the drive, it just takes the point and converts it to these words. So we have the start word, and then we create a second one to stop the drive. So when start is changed from a close to an open, so it'll enable it, and it will give the drive a stop, 043C, to the control word. In hex, I'll define that later, but we're only changing one bit, which is bit 6. Bit 2 through 6 is on, and bit 10. And we're just keeping 2 through 5 on and 10 still on and changing bit 6. That's the difference here, which is the ramp to stop. And then we're moving from the tag reference into the main reference value. That's kind of the basic network thing, what we're moving. We're looking at the tag for start and reference here to control the drive. Then the main routine, we're going to take that block, just enable it to enable the block. Then we download it back into the PLC. Same thing as before. We're going to override, load. Another different ways we can do these bitwise. So they're just always on. And I'll kind of talk about these bits. So they're just doing sub bits. So remember I just said bit 2, 3, 4, 5, and 10. Remember it's a different word. And second word though, that's why it's a different one, but yep, bit 6 to start stop. So instead of moving the whole word, we're just changing the bits. And same way, just moving the reference. That is it for this presentation. Now, I do want to show here, let me go, I'm going to change what I'm sharing. Let's see. Okay. So I'm going to show you where to get the function blocks. So we're going to go to danfossdrives.com. And to get the supporting, we'll go to service and support. And then downloads. Now the Danfoss website, it goes to danfoss.com. It'll show all the different business units on the side, but to kind of filter down to just drives, I click on drives. And we're presented with the My Drive suite is where we would download programs like MCT10. And where we want to go for Fieldbus configuration files is the third one down. So we have Fieldbus configuration files, so I'll click on that. And then we are presented with all the different configuration files, but the first one, as it is, we can change how it's organized by date. But we see there, we've did a big project with Danfoss to create new function blocks for all the different kinds of PLCs and such. And as you see, for people who do Ethernet IP or Rockwell, there is new add-on instructions for Rockwell Studio. And if we scroll down a little bit more, we see there is function blocks with TIA portal. Now I already downloaded this, so I'm going to bring up, excuse me. Back up. So when I download it, I will have a zip file. And I'm not sharing. Let me share my screen again. There we go. Okay. Once you download, you get the zip file for function blocks, TIA portal. You would unzip. So I'm going to just go into the zip. I'm going to copy and paste it to my C drive here. There we go. Inside there is instructions and a couple of different libraries in here. I'm going to open it up. And there you go. So when you open up the instructions, it does have step-by-step in here on utilizing the function blocks. So I'm going to scroll a little bit down and let's take a look at some of these. So they have a whole thing, what are function blocks and stuff like that. And it does show using the function blocks in TIA portal. And I believe I do have an area in here for using them in the old step 7. I don't see it in this instruction though. I thought it did. I do have instructions for that if anyone needs it then. But let's look at an overview for a couple of the different ones. So there is included is the basic control profile for the FC profile, which this is what the block will look like when you pull it in. So there, just as that, there's the enable of the whole block, address, enable the drive, input points, run, reverse, reset, and the reference, and you'll get out that's enabled. The drive is ready, whether it's in fault or warning, whether it's running or not, running on reference, the speed it's running. It also has motor current and communication error for the block. And it has basically everything I just said. Quick kind of function flow chart for how the block works. There is a block here for the parameter access channel, as we were talking about, if you're using PPO 1, 2, or 5. So you would ask what parameter, and you get your answer back. There's an FC Diagnostics, reading the alarm words and warning words. And then there's a block called the flexible FC block. This one's for reading the PCDs, and it's editable. A lot more to it than what that block is showing. As you enable things, it just grows, okay? And it's got a highlight of all the different things that are in it. All the control word bits, the status word bits, PCD. So you can open up everything that is available to the drive with this flexible one. There it is, opened up to almost everything in here. all these blocks are pre-compiled. So you do have the source code. You can edit them for your need. Had to be open. And it shows using, so the instructions go step by step. But you can edit these. You can see the inside code if you want to make changes. You can use them as is, or like I said, change them. They had to be open though, so that they can be imported in different versions of TIA Portal. Usually if it's stuck to a certain version, then you can't compile it in another one. So you're compiling it for your version. Okay. I do want to give a quick view also. There's the programming guide for Profinet, as well as there's one for Profibus. Again, it's same depending either which FC. This also, as it's not in here, it is for the FC 280. Also, if you're looking at that one. But the one I wanted to talk about, so the PPO types, this is in that manual. But like I was saying, the parameter access channel, the control word, reference word, and as they're shown here, it's kind of read and write and read in these. So the PPO 1 has a parameter, PPO 1, 2, and 4 has the parameter access channel. And then these are gray because these are preset in the drive. They can't be changed. And then the extra words, depending on the PPO you pick, is what is configurable in the drive. The other part I want to show is the control word structure as we were talking about. So this is the bit structure here for the FC profile. It is in this manual for the Profi drive profile. They're very similar to each other, just a couple bits different. But as I was saying, to start the drive, we came up with 047C, which is turning on bits 2, 3, 4, 5, 6, and 10. There's a data valid bit that must be on for the drive to obey this control word and the reference word. As you see, there are other bits for reset, jog, reverse, selecting the setups, controlling relays, and also preset reference selection, which is just the first 4. The other ones, as I wanted to draw attention, is 2 through 6. If you look, all on allows it to ramp, allows it to run, ramp, and then there's the main start. Depending on, through the FC profile, Danfoss FC profile, depending on which one is off is mostly how it stops. So you turn them all on, the drive ramps to a start, always using the ramp time. But if I want to ramp to a stop, I turn off bit 6. If I want to coast, like a fan or a pump, and don't use the ramp time, I use bit 3 instead. So the stop word will be different. Instead of turning off bit 6, I turn off bit 3. I can also, for industrial, I can use DC braking. I can do a quick stop. And the other caveat, one that's not a ramping, is a hold output frequency. I do want to say also in some of the settings, there's also a parameter for selecting what you want the drive to do when it loses communication. And in that, I'm going to quickly show MCT10.
Hey, Joe, could I butt in for a second and ask a stupid question?
Yes.
The drives themselves have coast and verse, which is what the coasting function is on the drive, there's no parameter you can go in and actually set your decel to coast like you do with a lot of drives.
Well,
on your
coasting
bit,
is
you have a
coasting.
coasting option.
That's letting the drive go, or letting the motor go and just using its own inertia to stop. So there is no ramp time in that when we talk coast.
Correct. But to choose that, it looks like you have a bit to choose coast or, coasting or not coasting. Where in the drive terminal block, you don't have that. So to me, logically, I almost thought it would say coast inverse instead of coasting for the bit to match the manual, so to speak.
Well, in a way, it is a coast inverse because I'm turning the bit off to coast.
Correct.
In the same way as the digital input is. The bit is inverse. It commands coast when the digital input is off. So I'd say in the same, it is the same. If I leave that bit off and I just use bit 6 to start, the drive will be coasting.
Right.
Because I didn't turn.
If you left start on that bit and you just cycled coasting bit, when you take it off coasting, like you do on a terminal block, the drive will just take off again.
Correct. So you could, in the one example where I always on coasting was bit 3 in there, so I had 2, 3, 4, 5, and I was toggling bit 6. So if I leave all the bits on and I just turn 6 off, it's going to ramp. If I swap that idea and I left on 2 and I toggled 3 for coasting and left on 4, 5, and 6, leaving start always on, and I just toggle 3. So when I turn 3 off, even though start's on, the drive will coast. And when I turn that bit back on, I'm no longer coasting. It will see start is on. It will start ramping.
Right. Yep. Exactly. So I'd be very careful with customers when I explain that to them. It's not necessarily a ramp function for coast or ramp. No. It's actually an enable disable to a point.
To a point, yes.
Yeah. Okay. Just wanted to make that comment.
Okay. So can everyone see my MCT10? I know it's a little small. Make sure I'm sharing that one. Okay.
You can see it.
Okay. It was orange, so I don't know if I was showing it. So so yeah, there's 2 different ways. I can connect through USB, or there's Profibus connection, but there's also the Ethernet. So I can actually connect to the drive over any of the Ethernet options through this Ethernet connection. And I can discover unaddressed drives through this. Let me do it again. I did it kind of quick. So I right click and use configure bus. Now I'm not configuring the port on the laptop. Windows does that. I'm configuring the bus, the network in this case. And this is where I can discover drives and I can set IP addresses here just for presetting them. But if they're all out there pre-wired, I can just hit the scan. And being I don't have anything hooked up to my Ethernet, I didn't find anything, but it would find drives just as though I was using the serial connection. And I can then configure the host name then and type it in instead of using the keypad. But I'll create a drive, I'll create an offline drive here to show some of these important parameters. So let's say I have one here. I was doing a Cascade one previously, but I'll create a drive here with Profinet. So in the Ethernet connections, as you see, it's already DCP. I will leave this alone. There is still manual or static DHCP and BootP, but Siemens PLC uses this DCP addressing. And then we can set the host name. Is this one offline? It's not allowed here, but I can set it through the drive. I have to look at that one later. But I'm not on a live drive, so Then there is a 9 group here for Profi Drive, which is the same menu here if you have Profibus. They left it in Profi Drive. The only thing different is I don't have an address per se in there. And the one in here shows the PPO type when it's connected in 922. It'll say none, it's grayed out. It gets that automatically from the PLC. I do not select the PPO here. It's selected in the TIA portal. But in here, I'm showing this is where I would set my extra words. And as I showed earlier for the PPO type, the control word and the reference word is preset. It's words 0 and 1. I can set other things, like if I wanted to change ramp times. Or set point if I'm doing closed loop. Okay. Readouts is mostly 16 stuff, 16 group, you know. Motor current is usually an important one. I could do reuse the drive as a point, kind of a point of presence for, you know, a proc sensor or something of that. So I can actually read the DC, where's that? There we go, the DC input. So that'll give me a bitwise connection to all the digital inputs on the drive, as well as you may have seen when I was looking the analog inputs directly, just read the voltage directly. Many things in here, but you may notice as far as writing, I don't have the motor stuff. I don't have setting the digital inputs. I can control digital and relays through here separately, or like I said, there's some that are preset in the control word. But it's so cyclically we're not writing or we don't change the motor parameters, but the parameter access channel, as I said, can go to any parameter utilizing its parameter, parameter number. Okay. Let's see. Oh, lastly, like I said, in the comms and options, we go to the general settings, and that's where it's already preset as option A. There's the 8-01 where we choose where's the control coming from. And by default, it will look at, the drive will look at both the digital input and, in this case, the control word coming from Profinet for control. So it can be controlled with both. Most commonly done this way for controlling, you know, through Profibus, but still have like safety stuff wired to the digital inputs. If I want to set to Profinet control only, I can do control word only. If I want to be controlled through digital inputs and the analog inputs, but use any of the serial communications like Profinet for monitoring, I can do digital only. Then Profinet can't control the drive, but it can still be used for monitoring. Or you can do both. When this is set to both, there is also a subset in the 8-5 group where we say individual controls of start-stop. How do I actuate based on these? Like coasting, as we were talking, it's a logic OR. I can take coast from both digital inputs or the serial communication. I can set this to be a logic and. They both have to be on for me to run. If either one, like coast inverse or something like that, goes away, I will obey either one, but they both have to be turned off. Or I can select bus only, or in that case, maybe digital only. Yeah, so I can select different ones. Start only comes from bus, but say coasting only comes from digital. The digital inputs on the drive. But changing this to one of the other, so it sets them all. This overrides that selection. The other one is it's talking about the control word timeout. This is loss of communication. The default is off, meaning the function is off. So if it loses communication, the drive will keep doing what it was last commanded. So if it was running at 45 Hertz and the cable came unplugged or someone turned off the PLC, the drive will continue to run at that command until the control word is updated. But we have other selections. Some machinery things we can stop and trip. Some, if it's a closed loop kind of control or something, we can go to a second setup. Maybe one set for closed loop with the pressure transmitter built right on. We can tell it to go to max speed. Commonly, this is something for like refrigeration, I'd say. We can freeze the output, but still show a warning, hey, something's going on. Or we can go to a jogging speed. There's different selections in here. If we go to a second setup, and as see, the drive does have 4 setups. We can have a PLC control and a local control in setup 2. Then there's the 805, which is, well, if the PLC comes back, do I go back to setup 1 or do I hold in setup 2? Then there's a time delay in there for when it carries out, when it loses communication. By default, 60 seconds. We can set it all the way up, down to 1 second, up to 18,000 seconds. So, and that is it that I have right now for Profinet. At this time, I'd like to invite anyone that has any questions or anything I may have missed. Anyone have any questions?
Nope, looks good, Joe.
Okay. Well, I thank you all for joining me. I appreciate any feedback. I will send out an email. I'll try to get a list of everyone that was here, and I will email a PDF copy of the presentation that I showed, as well as some of the links that I provided, to download MCT10. I can include the function blocks if anyone wants. You also then will have my email. You can email me back if you have any questions. But again, thank you very much for coming. Everyone stay safe, and hope to talk to you and work with you in the future.
Okay,
Thank you, sir.
Thanks, Joe.
Thank you very much.
Great job, Joe. It's Carlin. I'm going to call you after the presentation. Thank you.
Okay, thank you.